back with chapter 3. Okay, we will start with chapter 3 halfway through. Okay, and we'll try to see how much of chapter 3 can be done. Okay, if you can't hear me or you can't see me or you can't see the slides, please inform me, or at least please message me. All right. Okay. Can you all see the slides moving? 3.2. Can you all see this? Is it moving? Okay, the slides are moving. Okay. All right. So let's start back with thread. What do we mean by thread? All right. So in chapter 3, what we have addressed is we have talked about what is program, what is a process, and we have also touched about what is a thread. Okay. So a thread is basically subsets of a process. So in this particular example, you have a website, okay, and it's showing yahoo.com, okay, and you have several sub processes running at the concurrently, okay. So on this side here, you have the weather forecast. On this side here, you have the advertisement. Here you have a search button. So all of these sub processes are working together. So basically, a thread. Yeah.
Tak dapat tengok slide.
Tak dapat tengok slide. Okay, I'm at slide. Nampak thread tak nampak? Oh, the slides. The slides. Is the slide moving now?
No.
No. Okay. Okay, good. Sekejap. Let me just reset balik. Okay. Hold on. Window. Better look at the window. Share. Okay, now can you see the slides moving?
Yes, sir. Thank you,
Yes,
sir.
sir.
All right. Okay, good. Okay. So over here, over here, you have the Google Chrome, as I mentioned just now. So you have several sub processes running at the same time. Okay. So these sub processes are called thread. Okay. So what is a thread is basically, you can just imagine you have a long wire, and dalam wire tu ada pecahan-pecahan. There is a fan, there's light, and there's something else lah. Okay. So in the same wire, everything is on, but if you cut the wire, cut the power supply, and everything goes off. So same goes to thread. Everything is running under one process. So kita ada beberapa thread running at the same time. So if you look at Microsoft Word, for example, Microsoft Word ialah satu proses. Okay, document 1 is a process. Then dalam document 1 tu, as you're typing, you are the grammar check, you are the save check, all things are running at the same time. So these things are called threads. Okay, these things are not called thread. Okay, so this is the definition of thread. Okay, a thread is a separate flow of execution. This means that your program will have two things happening at once. Consider having multiple programs counters per process. Okay, so the example here, bawah ni, let's use Microsoft MS Word as an example of process in operating system. When you open Microsoft Word, the OS treats it as one process. Okay, Microsoft Word is one process, which means they are the memory, space, resources, and so on and so forth. Inside that particular process, there are multiple threads. Okay, dalam proses yang sama, there are multiple threads. Okay, so what are the examples of threads in Microsoft Word? Detecting keystroke, mouse click, updating menus, redrawing the screen, and so on and so forth. Okay, so why did the manufacturers of operating system create a thread? Sebab when you have a process, the OS has to allocate RAM, memory, hard disk space, and so many things. So you have multiple processes, they can allocate. So your RAM size akan jadi smaller. Alright. So over time they said that, why not kita ambil proses tu, letakkan dalam satu proses yang besar. Alright. So all those small sub processes are now under one process. So when you have all under one process, so you will save. Okay, you will save memory space. Okay, that's the main idea lah. Okay, so now In operating system, we want to maximize the CPU usage, or in the computer system as well, we want to maximize CPU usage. So maximize CPU usage is you want to make sure that the CPU is always busy at any given time. Okay, so you want to make full use of it. Okay, so another example is, for example, let's say you own a big car, but you only travel, or you own a big car and you only travel two people inside a car. So that is not maximizing the car. So in operating system, we are also looking at maximizing the CPU usage. If the CPU usage is not maximized, then there is it's not to say it's not good, but then it's a waste. Okay, you want to run one, you have no programs to run. So what did the operating system do? Since it's running multiple processes, it switches between processes at a very fast speed, time sharing lah. That means sekejap dia buat proses ini, and then sekejap dia buat another process, sekejap another process. So all these processes dia akan duduk dalam satu queue, okay, which the CPU akan tukar-tukar, will change the process. Look in the box here. Process scheduling ensures that each application gets a fair share of CPU time. For instance, when you click your browser to load a web page, the browser gets a slice of CPU time to execute. When you switch to your Microsoft Word or word processor to write a document, it gets a share of CPU time. The OS process scheduler constantly switches between these processes to provide a responsive and smooth user experience. It balances the allocation of CPU resource among these processes. So 1 minute you're doing PowerPoint slide, and then you switch to your Google Chrome. So CPU will allocate the CPU time accordingly. So that bila you switch, let's say you're now using Microsoft Word or PowerPoint, and you switch to your Google Chrome, immediately you can use it. You don't have to wait for a while, or there's no delay. So the CPU is giving maximum time for every one of the process. Okay, so here we have a diagram showing each process coming into the CPU. Ada beberapa proses coming into the CPU. However, each process is different. Some processes is just to display information. Web browser is just to display information. Ada proses yang request input output. Contohnya Microsoft Word. Microsoft Word is a process which only processes something if ada input and output. Yalah, you buka Microsoft Word, but you look at it, it's nothing. You have to type in something, only then it happens. Okay, so other certain process is just merely to display. So there's only output. There's no input yet. Okay, so what this diagram is doing is the CPU is switching between certain processes. Okay, switch. That means if the process is waiting for input, it will switch to a different process. And each process, they are the time slice there. That means each process is given certain point of time, then they can switch, they can tukar. All right, or it's waiting for interrupt to happen. Example, okay, it's waiting for interrupt to happen. Let's say you open your Google Chrome, but you don't do anything. So once the user interrupts and clicks something, then the process will start. Okay, and there's also another term here, fork a child, meaning daripada satu proses dia boleh dibahagikan kepada multiple process. Forking a child macam thread. And you open one Microsoft Word, dalam itu you ada grammar check, you can save your document and so on and so forth. So each of these processes yang run kat sini, dia ada time slice, dia ada time that it changes the process. So each process will be sitting in a ready queue, and bila CPU tu dah kosong, baru dia akan masuk dalam the CPU here. If you remember the 5 states in the process, which is new, ready, running, waiting, terminate. Okay, so each process will go through from new to ready. Okay, dalam ready tu dia akan tunggu. And where is this ready situated? It's basically situated inside your RAM. Okay, so there are several types of processes which happens inside the operating system. Ada beberapa jenis. Okay, look at point number 3 down below here. Ada proses yang input output bound. That means dia banyak proses itu banyak buat kerja-kerja input output. Contohnya Microsoft Word, it relies mainly on an input and it does a lot of output. Okay, PowerPoint also input output. Photoshop also input output. You have to input something to draw something or to get something on the screen. But ada juga proses yang banyak buat CPU bound. Dia banyak buat calculation. Contohnya, if you have heard of SPSS, this statistical software, dia banyak buat kiraan, that is CPU bound. Dia banyak nak kira ni. Or Canva is a CPU bound process because you nak buat a layer of pictures, sound and weight. These are all CPU bound. Okay, less on input and more of CPU bound. So between these two processes in the previous slide, the CPU kan dia bertukar between two processes. So it has to choose which type of process it has to go through. Adakah dia nak pilih semua input output atau CPU bound process? So what the operating system will do is it will choose between either satu buat CPU, satu buat input output, satu buat CPU, satu buat input output. It cannot only, dia tak boleh pilih all CPU bound and then selepas itu buat input output, then proses tu akan hang. So that's why point number 4 here, a good mix of proses tu kenalah bertukar-tukar. Sekejap is CPU, sekejap is input, sekejap is CPU, sekejap is input. So there are two scheduler. Scheduler ialah a software which sits inside the operating system yang akan pilih types of process. So the CPU chooses, dia akan pilih proses jenis CPU. Sorry, the short-term scheduler akan pilih proses jenis CPU, which CPU bound ni, bawah ni. So this scheduler will choose. A long-term scheduler pula, dia akan choose program-program yang input-output bound process. Because the CPU does not know ini proses ni panjang ke pendek ke apa, dia tak tahu. So the software within inside the operating system, which is called the short-term scheduler, kerja dia ialah, its job is to choose the CPU bound process. Yang long-term scheduler pula akan pilih the process yang input-output only. Okay, so this thing will go on in the CPU. Okay, so examples of an output bound process, input-output bound process ialah web browser, because it's just you need. Okay, it spends a significant amount of time waiting. Dia menunggu input output baru dia boleh jalan. Okay, a CPU bound process, it's a process that requires a lot of computational power. Spends most of its time actively performing computation. You got video encoding, 3D rendering, scientific simulations. These are all CPU bound process. Okay, so the short-term scheduler, as I explained just now, is a type of software which sits inside the operating system, which chooses proses yang CPU bound, yang lama. Okay, macam ni kat sini, example, the user is running web browser, video player, ni semua proses yang lama. Okay, yang heavy usage, compression. Okay, these are all CPU bound processes. There are long-term scheduler pula. Okay, it's mainly on input-output processes. Okay, that means a request daripada user. Okay, just to input something and output something. Alright, so basically that's a function of long-term scheduler. The degree of multi-programming bermaksud when the operating system chooses between CPU bound process and input-output bound process, it has to make sure that the number of processes that are currently executing in the program, it has to make sure what is the number. That means dia tak boleh ada 10 CPU bound and 3 input-output. It has to be balanced. It has to be balanced and it has to be concurrent, one after another. In this example, suppose a computer system has 4 GB of RAM and each process is allocated 1 GB of memory. So ada 4 gig dekat RAM and ada 4 proses. In this case, the maximum degree of multi-programming would be 4. Sebab dia ada 4 gig, so maximum yang dia boleh pergi 4. Provided each program dia ambil 1 gig lah. Okay? If there are more than 4 processors, some of them will need to swap out of the memory and stored on the disk until they are ready to be used. Kalau ada lebih daripada 4, means dia boleh maximum of 4. So they have to take out one and put in a disk. Disk tu kat mana? When you say this word disk tu, it means you have to shut down and go back to your hard disk and kosong, masukkan lagi a new process. So when this happens, this is called medium-term scheduler. Medium-term scheduler is a situation whereby your RAM is full and the CPU or the OS will swap satu proses keluar, masukkan satu proses baru. Okay, macam example tadi, you ada 4 gig of RAM and maximum proses yang you boleh pergi 4, tapi you nak masuk proses 5. So what does the OS do? It will do something called the medium term scheduler. Keluarkan satu proses yang lama tak buat apa-apa, yang tak buat apa-apa, keluarkan, masukkan proses baru. This is how it goes. The same thing is also done inside your phone. Dalam Android phone, we have the pause activity. This is where medium-term scheduler is used, because this application is rarely used. It's rarely used, so it has been paused so that it's out of the memory and your memory is not wasted. So a new process can be used in that particular memory space. So in the mobile system is slightly different from the laptop. Okay, mobile system dia tak ada CPU bound and input output bound. Dia cuma ada foreground background process. Kalau laptop or computer system dia ada 2 jenis. One is CPU bound and one is input output bound. Okay, a CPU bound is banyak kerja-kerja CPU, computational, rendering movie. Input output bound process is banyak input and output, waiting for an input and output, so on so forth lah. But in a mobile system, it's slightly different. Dia ada 2 jenis saja. One is called the foreground and one is called the background process. Okay, background process is multiple background process in memory running, but not on display and with limits. On your phone now, you're running WhatsApp. WhatsApp is considered is a background process. However, when you open the WhatsApp message, WhatsApp program itself, it now becomes a foreground process. Okay, so there are 2 jenis lah. Alright, and each process is limited to the RAM size and the task, because the RAM size inside the phone is very small, so it's limited. Okay, so Android runs on foreground and background process with fewer limits. Background process uses a service to perform tasks. Service can be kept running if background process is suspended. Okay, so some services can run, some services can run. Okay, so service dia tak ada interface. Macam biasa lah, when you have your WhatsApp running, you don't actually see it running, but it's there. You can shut down, you can close the interface of WhatsApp, but can still run. Macam you buka all your phone, in your phone, kalau Android tu, you tekan button tengah tu, you can clear or you can end task or everything. But actually your WhatsApp is still running. Cuma you don't have a screen. So the WhatsApp which is running without the screen is called a background process. And when you open up the WhatsApp, it's called a foreground process. Okay, this context switch is whereby you switch. Okay, you switch between the CPU switches between 2 processes. For instance, when you type in Microsoft in Word processor, okay, a process while a song is being played in the background, the CPU switches between processes and decodes the audio for backplay and possible loading a new content. So this switch happens many times per second, so it feels seamless to users. So it happens. Even now, kalau saya main my music behind my screen laptop, you don't see it, but it's actually happening behind the screen, so it's running very fast. So context switch is also there. Okay, so if you go back to a few slides, you'll see medium switch and you'll see context switch. So what is the difference between medium switch and context switch? Context switch is happening as we talk. Dia kan bertukar proses. Okay, sekejap proses ni, sekejap proses ni. Medium switch ni berbeza. Okay, macam ni. Inside the RAM there are several processes. Okay, let's assume inside our RAM there are 4 processes. Okay, and the RAM can only take a maximum of 4. So bila proses 5 nak masuk, tak boleh. So one process has to come out. So this process which comes out from the RAM is called medium switch. Okay, medium switch. Dikeluarkan daripada RAM. Tetapi inside the CPU, when it's changing between 2 processes, bertukar, that is called context switch. Okay, context switch. Context switch happens inside the CPU and medium switch happens inside your RAM. Okay, medium switch, kita keluarkan proses itu, masuk proses baru. Keluarkan proses, masuk proses baru. Context switch, tak buat apa, but you switch the program. Okay, sekejap dia tengah proses A dalam CPU. Sekejap dia bertukar proses B. Sekejap dia tukar proses C. Sekejap dia tukar proses D. And masa dia tukar proses, the old process is just kept inside the RAM. Okay. Alright. So, before we continue, these are the terms that you need to understand. Context switch, CPU scheduler or job scheduler, and we have long-term scheduler, and we have medium-term scheduler. Okay. So, what we have medium-term scheduler sama dengan yang tadi dah. Okay, medium-term yang explain tadi dah. Okay, so okay, next we look at how processes are being operated. Okay, macam mana kita nak on a process? How do we create a process? Okay, how does the operating system create a process? Okay, for us as a user, we create a process by simply double-clicking a program. Kita double-click je and the process appears. Tada, dah appear lah. Okay, tada, dah appear. Okay, that's done. Okay, but that's for us to understand. Tetapi dalam Microsoft Word, okay, dalam operating system dia berbeza. Okay, it has to create a process and terminate a process. So once you double click a program, it actually creates a process. So how does it? We have to understand the definition first. Parent process creates child process. So once you double click a program, it becomes a process. Tetapi you buka document 1, it becomes a child process. Okay, child process. Okay, these are the terms that you need to understand. So dia akan create a child document 1, tab 1. Kalau dalam web browser, we've got a tab that is called a child process. Okay, what is a thread? Thread itu dalam proses tersebut. But a child process ialah daripada satu proses yang besar tu, daripada Microsoft Word yang besar tu, document 1, document 2, document 3. Document 1 tu ialah child process. So when you kill the parent, tutup program besar, everything disappears. Okay, so this is what happens lah. Okay, so but ada juga yang dekat sini, okay, here you have a term called fork process. Dia bahagikan sama rata program. Contohnya macam ni lah. Okay, let's say you are doing a C++ program and you want to determine whether the input from the user ialah nombor prime atau tidak. Okay, so you create a function. This function is to check if the input by the user is either prime or non-prime or not a prime. Okay, so the user will input a number. Tetapi bila number tu dah input, automatically another process which is called the prime process will take over. Okay, so this prime process ialah dalam satu proses yang besar. So this one will do a separate process which is to check the number whether it is a prime or not prime. Okay, so we call this breaking of this process called a fork. Something like a fork lah. So dia pecah kepada benda lain. Okay, dia pecah kepada benda lain at the same time. User masuk satu number, automatically dia akan buka satu lagi program to check whether the number that you have inputted is called it's a prime or not prime number. So sama juga dalam Microsoft Word. When you open a Microsoft Word, automatically the process is now broken into. Okay, tiba-tiba dia akan keluar autosave. Autosave is automatically there. So these are all examples of forking a process. Now, when you want to terminate the process, okay, kita habis guna process, how do you terminate? As simple as just click button X. Click button X, or click the red button, habis dah. But what actually happens inside the computer system is the OS will execute a system call, a special function called exit. This exit akan automatically tutup. But if the documents are not saved or not done yet, then automatically dia akan pergi kepada another function which is called the wait function. Itu yang biasa you kena. Bila you buat document and then you click X, you get a message. Do you want to save? Yes, no, cancel. That is a wait. However, sometimes it can also happen in abort. Bila proses tu dah lama sangat, you end task, that is abort. Or tiba-tiba blackout. Blackout, that is also considered an abort function. So bila abort, dia akan hilang semua ni lah. Dia akan hilang semua. Kalau wait, dia wait for the user to input what is next. Okay, I don't think this is not important. Don't understand this. Now, the last topic for today is called inter-process communication. Now, we want to understand bagaimana dua proses bercakap dengan each other. Now, so bila dua proses ni bercakap to each other, there is something they need to share. Okay? Imagine a scenario where you have two programs. Satu, a video player with subtitle processor. A video player and a subtitle processor. The video player play a program is responsible for playing a video. Okay? Video. While the subtitle processor is responsible for processing the subtitles. Okay? Dua program berbeza. Satu is to run the video, another one is to process suara daripada video itu and keluarkan subtitles. Now, macam mana dia buat? So the video will play and the subtitle program akan baca video itu to see what to translate, how to translate. Okay, how to translate. Alright, how to translate. So the video has to run first and then the subtitle program. Video run first and then the subtitle program. The subtitle program cannot go first before the video. It has to go concurrently. So how does this mechanism work? Is basically the video akan run, tetapi dia akan letak output dia dalam satu shared memory. Okay, dalam satu location which is inside the RAM. Right? And the process and the subtitle program, dia akan baca file-file daripada RAM tu untuk dia translate. That is how these two processes communicate. And this is called shared memory. Okay? Shared memory is important because two programs depend on each other. This allows the program to operate asynchronous or independently for each other while still being able to synchronize and share the data. Okay? So video tu dah nak run, dia akan letak video tu dalam satu share location and the subtitle program akan ambil that location and dia akan translate lah, and dia akan dua-dua akan keluar. Okay, but dua-dua will need something. Okay, they will need something which is called shared location to actually allow the process to communicate. Okay, so these are certain examples of inter-process communication. Ada yang cooperating, that means they cooperate within each other. Okay, they cooperate within each other. Ada yang independent, so setiap satu proses is independent. Tetapi bila mereka bercakap, they talk to each other, they communicate, is called the inter-process communication. So inter-process communication is a mechanism used by the OS to allow different processes to share data or communicate with each other. Alright, so inter-process communication sends message. Okay, dia akan hantar message. Contohnya kat sini, when a user sends an email using Gmail, the email is sent as a message to the recipient's server, which is running in a different process. The recipient's email server receives the message, stores it in the recipient's inbox, sends notification to the recipient client, which is running in a different device. Okay, So ada satu tempat di mana dia akan, okay, they will send it there and this to the server, and dalam server ni lah baru dia akan send notification to the user. This is how inter-process communication works. Okay, so here I think you can read it on your own. What is the difference between cooperating processes and independent processes, and these are the advantage and disadvantage. Okay, this one, yeah. Okay, the next, I think these are all just the same things which I've already talked just now. Okay, I think that's all for today. So what we have done today is we have talked about thread. Okay, we have talked about medium-term scheduler, short-term scheduler, long-term scheduler. We have talked about context switch, and we have also talked about inter-process communication. Okay, so please read up on this, and inshallah I'll see you in the next class. Thank you so much for coming in today. We'll just do a half an hour class because they only have a few more slides in chapter 3. So that's all for today. Thank you so much. Please sign your attendance, and I'll see you in the next class. Thank you. Assalamu alaikum.
Waalaikumsalam.